Lesson 8.3, Multiplying Rational Expressions. In the last lesson, we learned how to simplify a rational expression, and in this lesson, we're going to learn how to multiply them. This is the same principle as multiplying fractions, and we're going to want our answer to be in simplest form, and we can use one of the two methods that we use for multiplying fractions. Method 1 is we first multiply and then we reduce, and then method 2 is we reduce and then we multiply. So I have the same multiplication, and I'll show both methods. Apply. And I'm left with 5 times 7p, which gives me 35p, over 9 times 4, which is 36. Now when I have expressions in there, b minus 2 over b minus 1, nothing will cancel. b plus 9 over b plus 9, and b minus 1 over b minus 2. What I want to do is I want to look at everything across the top and everything across the bottom, and everything that cancels or matches I want to. So I'll cancel my b minus 1 and this b minus 1, this b minus 2 with that b minus 2, and b plus 9 with b plus 9. Since every single thing canceled, I'm left with a 1 over a 1, so this multiplication will result in an answer of 1. Looking at 4, 7b plus 4 on top, 7b plus 4 on the bottom, 8 on top, 8 on the bottom, nothing else matches. So once you've done all your canceling, whatever's left, you just write that down. So I have b minus 10 times b plus 4 over 10. Now, I haven't listed any of my excluded values yet, so we can't forget to do that. If I set each of these equal to 0, what I'll find is that n can't be 0 because that's the value that will make the denominator 0. Here I'll have p cannot be 0 because that's the value that would make that 0. Here, b minus 1, b plus 9, b minus 2. So b cannot equal 1, negative 9, or positive 2. And now, since there's no b's left, it's kind of maybe seems pointless to list this, but you just need to get into the practice of always listing them because it'll become important when we're solving equations. Here I have 7b plus 4 equal to 0. So when I solve that out, I'll get 7b is equal to negative 4. So b would be negative 4 over 7. So this is what b cannot equal. All right, let's look at some more examples. In our last examples, everything was already factored for us. In these examples, we need to factor. So our first step will be to factor. Okay. 4n minus 24. 4 and 24 will both divide by 4. So I get n minus 6. 1 over 9, n minus 9, nothing factors out. N minus 6 cancels the n minus 6. Nothing else will cancel. 4 times 1 is 4. Nothing, and I have n minus 9. Now, I still need to list my excluded values, so I have to solve these two equations, and I get n cannot equal 6 or 9. Okay, so we need to factor the numerator and the denominator of this first expression. I'm going to rearrange this though, and I'm going to pull out a -1 so that my n squared is positive. That'll make it easier to factor. So I'm going to rearrange it. So my n squared becomes positive, my 3n becomes positive, and my 70 becomes negative. I'm just going to rewrite everything exactly the way it was. Okay, now I'm going to factor. I'm looking for two factors of 70 that will give me a difference of positive 3. So I'm going to make an x over here, and I want to add and multiply. I want to multiply to make a -70 and add to make a positive 3. So the first thing that comes to mind for 70 is 7 and 10, and 7 and 10 do have a difference of 3. I want my 10 to be positive and my 7 to be negative to give me that positive 3. So I'll have -1 times n plus 10 times n minus 7. For my denominator, I want my addition to give me a positive 9 and my multiplication to give me a -10. So things that will multiply to make 10 that have a difference of 9 will give me a positive 10 and a -1. Because 10 plus -1 is 9, 10 times -1 is -10. So that gives me n plus 10 times n minus 1. And I have 1 over n minus 7 still. Now I want to cancel everything that matches from the top and bottom. So I've canceled my n plus 10s, and I have n minus 7s. And after everything's canceled, I have a -1 times 1. That gives me -1 over n minus 1. Now I do still need to find my excluded values. I have n plus 10, n minus 1, and n minus 7. So n cannot equal -10, +1, or +7. Okay, here we have some more complicated ones in that there's more factoring to do. Looking at my first fraction, I don't have trinomials, I have binomials, so I can only factor out the greatest common factor. I have an 8 and a 24. Both of those will divide by 8, and they both have an x in common. So this leaves me with x minus 3. And in my denominator, I have a 16 and a 48, and they'll both divide by 16. I have 3 x's and 2 x's, so I can take 2 out, and I'm left with x minus 3. On this numerator, I have a 40 and a 56. They'll both divide by 8, and they have 2 x's in common, and that leaves me with 5x plus 7. And now I have to factor my denominator. And I'm going to do that down here. And I want to multiply 5 times -70. And the reason I'm doing this is because I'm going to turn this trinomial into a factoring by grouping. So 70 times 5, that gives me -350. So I'm going to be looking for two numbers that'll multiply to make -350, 50, not 05, and then add to make -43. Now, I am not up on all of my factors of -350, so I'm going to start factoring this, and I'm going to have 10 and 35, which gives me 2 and 5 and 7 and 5. Now, 2 and 7 is 14, and 5 and 5 is 25, but they're not going to give me a difference of 43. 10 and 7 is 70, and 5, that won't give me 43. I have 10 and 5 is 50 and 7. 50 and 7 do have a difference of 43, so I want a negative 50 and a positive 7. Now I want to arrange this so that I replace the negative 43 with the negative 50 and the positive 7 because those will add up to negative 43. I want to put the negative 50 with the 5 and the positive 7 with the 70 because they have something in common. I do have videos on factoring, so if you need to go back and review that, you'll want to do that for this unit. We'll pull out 5 and x, and that leaves me with x minus 10, and I'll pull out 7, and that leaves me with x minus 10. So this will factor to 5x plus 7 times x minus 10. And you can write that in either order. I just lined these up because it's prettier. So I'm going to cancel everything that matches. I have x minus 3 and x minus 3, 5x plus 7 and 5x plus 7. Now I have an 8 and a 16. These will both divide by 8. And x squared, this x will cancel out one of those x's. And if I multiply that all, I'm left with 8x squared over x times x minus 10. But I can still reduce these two x's. This one x will take away one of those, leaving me with 1x. And so my final answer on this will be 8x over x minus 10. I still need to do my excluded values. 16x squared, if I set that equal to 0, I have that x can't equal 0. X minus 3 gives me that x cannot equal positive 3. X minus 10 gives me that x cannot equal positive 10. And then the 5x plus 7, just do that down here. If I set that equal to 0, I get that 5x is equal to negative 7. And that means that x would be equal to negative 7/5. So x can also not equal negative 7/5. These are all of the answers or values that will not work for x. Okay, so this one's a little complicated. We have a lot of factoring to do, but I want you to go ahead and try to factor this. And then I will walk through it step by step because we've got some y's in there, but I do want you to pause the video for a little while, try to factor it and see if you can eliminate, and then unpause the video and come back and see how you did. Like I said, I will walk through it. Okay, so x minus y we left alone. Then I had x squared minus 2xy plus y squared. This is a perfect square trinomial. It's in the form of a squared minus 2ab plus b squared. So we can factor it to a minus b squared. So x minus y times x minus y. Then I had x squared plus xy minus 2y squared. So if I did x plus 2y times x minus y, I get x squared plus 2xy minus xy minus 2y squared. So I factored that. And then I had 2x squared plus 5xy plus 4y squared. 2 times 2 is 4. So I knew that I needed to have a 4 and a 1. So I did 2x times 2y, that gave me 4xy, and then y and x give me the other xy, so they add together to make the 5. Then xy and x minus y canceled with x minus y here, and then this x minus y cancels with this x minus y over here, Then x plus 2y cancels with x plus 2y. Since everything canceled in the numerator, my numerator becomes 1, and I have 2x plus y left in the denominator. Now my excluded values were a little bit different. I had to solve this for both x and y. So x equals y. So x cannot equal y, and y cannot equal x. And then I have 2x plus y equals to 0. So that gives me 2x is equal to negative y. Sorry, that should have been a negative there. Which gives me x is equal to negative y over 2. And I have x plus 2y is equal to 0. I forgot the 2y. So x cannot equal negative 2y. And then I have to go back and solve those for y as well. So y can also not equal negative 2x. And then x plus 2y. So 2y is negative x. So that should also be negative. So y and x cannot equal each other. They cannot equal negative y over 2 or negative x over 2, and they cannot equal negative 2y and negative 2x.